I have a logic puzzle for all of you. Here we have a little gray box within a big blue border, and to the left of it we have two button indicators. When I press on the W key, the W lights up, but nothing's happening, at least for a few seconds. Now we're going to press the S and send it back down, except I'm going to let go now. The box is still moving even though I'm not pressing anything. So the puzzle is, what is happening to let this behave like this? Why don't you take a moment to think about the puzzle and then come back to this? Now, when I'm talking about solving this puzzle, I mean, don't worry about the code or anything that's happening within the project itself. Think about what is the logical steps? What is actually happening here? So we have to identify what the action is. So first, we have a box. And then we have a button. So when we press the button, something is happening, and then the box moves. So what would you call that? That's when the button is pressed. That's the first thing. What's it doing? It's creating a charge. So you're charging up the potential energy, and then the box then releases that. So we're spending the charge. But importantly, it's moving. So we have three things that are happening. We're charging it up, we're moving an object, and then we're spending the charge, even when we're not charging it. So that's just the first step. We've identified that something is being charged up, something is moving, and then the charge is depleting. Now here is where solving the puzzle starts. Let's break the puzzle down into two pieces: the button and the box. Now, why is it important that we separate these two things into two different items? Well, one, when pressed down, causes the other to move. So there's the action and then the reaction. Now, when the button is pressed, something begins to fill. And when that is filled, this is also filled. Now, you may have missed it, but when this button is pressed down, eventually this box moves. So what happens is this actually gets full. And if that gets full, then this gets full too, because there's only so much you can fill it up before it's full and then it moves. Now finally, for the button, as soon as the button is released, let's say that that makes it empty. And if that gets empty, then also the box becomes empty. And a funny thing about that is the box doesn't become immediately empty. So there's a moment where it is emptying. Here we have a grid, and it'll make sense in just a minute. So what we're doing is the button has a fill state, it has a full state, and it has an empty state. So it's filling when it's pressed down, it's full eventually, and then when the button is released, it's empty. Everything that it was filled up with moves over to here, into the box. So as this is filling, the box is filling. And when this is full, the box is full. And when this is empty, it is emptying until it is fully empty. So at this point, we start doing the logic part. This is called a truth table, true-false table. So when filling is true, it is also filling in the box. And these are all false. These cannot happen while it's filling. Then when the button is full, then you could say that the box is full. And when it is empty, you could say that it is emptying or it is empty. Both these can possibly be true. at the same time as while it's filling, it could also be still emptying in this model. But that's a rare case, and we'll get into that. Okay, I've organized everything into a easier chart to read. So the button can be filled, it can be full, it can be empty. The box can be filled, full, empty, emptying, or empty, and it moves. So while it's filling, the box is filling, and it's not moving. When the button is full, the box is full, and the box is moving. And when the button is empty, the box is emptying, so it's moving. But if the button is empty and the box is empty, it does not move, so it's false. And finally, the last state is if it's filling, there's also the possibility that it's still emptying. As we come back to the puzzle box, we can see this in action now, with these values written over top and beneath the box itself. So as I'm pressing W, you can see a buffer and charge amount go up. When I release it, the empty amount decreases as it moves. So as I go up and I release, the weight amount ends and the empty amount ends. So it charges up for a little bit, let it go, and it moves. In the example that we just saw, there were 5 variables that we have to take into account that made that whole system work. First, there was the charge amount. This was the amount that charged up as the button was pressed, and it equaled the buffer amount. So as the charge amount up, the buffer was equal to these two things. So the buffer equals charge. So as soon as the charge amount is released, the buffer stays in, and then it gets transferred over to the empty amount. And then there's also the weight amount to take into consideration. So the weight amount is the time it takes until the box begins to move. And how we figure that out is the box doesn't move until the fill max is reached. So once the charge amount hits the fill max, the box moves. But if it doesn't reach the fill max, it gets sent over to the empty amount, where the weight amount is calculated by taking the buffer, the max, actually, minus the buff. And that equals the weight amount. There are almost definitely more than one way to make this system work, but after reviewing all the elements that we have gone over, you should be able to make this on your own in whatever coding language that you would want. I hope you have enjoyed this today.